Okay, in this video, I'm going to show you how to solve some 2 and 3-step equations. Starting with number 1, 4x minus 3 equals 33. Now, what I tell my students is to take a ruler or a protractor and draw a vertical line going through the equal sign. So they keep the equal signs lined up. Now, we're looking here at the left side. We're trying to get x by itself. So eventually I'll need to get rid of the 4, but before anything, I've got to get rid of this -3. So I want to move the -3 to this side, and I have to do that using an inverse operation of subtraction, which would be adding 3. So we do +3 on both sides. Now, additive inverse is like -3 and +3, sum to 0. So I can just cross them out, okay? And we bring down this 4x. So we're going to write 4x equals. Now you want to draw a line, okay? And you're just going to do addition. 3 plus 3 is 6. 3 plus nothing is 3. So 4x equals 36. It's important to remember that there is really multiplication going on between that 4 and that x. And so what we're actually looking to do is the inverse or opposite operation from multiplication, which in this case would be division, okay? So we need to divide both sides of the equation by something. And that something is something we call the x coefficient or the variable coefficient. That's the 4. So we consider the 4 to be the coefficient of the variable, and we will divide both sides by the coefficient of the variable. Cancel, cancel. Those 4's divide by each other to give 1, and we don't write the 1, we just cancel them out, and we write x. X equals 36 divided by 4. Well, 9 times 4 is 36, so 36 divided by 4 must be 9. In this case, the problem resolves to just x equals 9. So we'll put that in a little box and move on to the next problem. Let's look at number 2. $7x plus 55 equals 104. Okay, so first things first, let's get that ruler out and draw us a vertical line just to keep things in order. All right, so your eyes should instantly be drawn to this plus 55 because that's the first thing we need to get rid of, right? Ultimately, we want the x by itself, so we have to get rid of the 7, but we can't do either of those two things before we get rid of the 55. And we're really just going to move the 55 over to the other side of the equation, and we do that by doing the inverse operation of addition, which is subtraction. And we're going to subtract 55 from both sides. If we only subtract from the left side, we're not in balance because we're out of balance. So we have to subtract from both sides. Now, 55 minus 55 is 0, so we just draw a line through it, canceling out. We say additive inverse is sum to 0, so we cancel it out. And now we're going to write 7x equals. And we're going to draw a line here. Now we're going to perform subtraction. I can't take 5 from 4, so I'll borrow, but I can't borrow from 0, so I'll borrow from 1. This is 0. This becomes 9. And this 4 becomes a 14. Remember, we add 10. So we take 14 minus 5. We get 9. 9 minus 5 is 4. So now I have 7x equals 49. Over in my head, I'm thinking, well, 7 times 7 is 49. So that's got to be something. Remember, this is 7 times x. So to isolate the x all by itself, I'm going to divide both sides by the x coefficient, which is 7. We'll divide both sides by 7. Okay. And we will cancel those 7s out on the left because they're on top of each other. They divide out to 1, leaving behind the x equals, well, 7 times 7, 49. So 49 divided by 7 must be 7. X equals 7. Let's put that in a box. Let's move on to our next problem. All right, this one is a little bit different. Number 3. 1 over 3x equals 4 over 15. Okay, well, first things first, we start by drawing our vertical line. Now, remember, we are already at the point where we're going to try to get rid of the x coefficient, which in this case is 1/3. And remember, 1/3 is being multiplied by x. As a matter of fact, over here, 1/3 times x over 1 is really what's happening. So what we'd really like to do is divide both sides by 1/3. Okay? Don't write that. But that's not how we express or write dividing by 1/3. Instead, we say flip it, or we say invert and multiply, or we say multiply by the reciprocal. A lot of different ways to say the same thing. What we're really saying is we want to multiply both sides by, if this is 1 over 3, if the x coefficient is 1 over 3, we want to multiply by 3 over 1 on both sides. And I'll show you why here in a second. If I multiply by 3 over 1, I've got 3's in the numerator and in the denominator. Okay, so I'm just going to show this longhand one time here. So 3 times 1 is 3. Over 1 times 3 is 3. So I have 3 over 3x equals 4 times 3 is 12. 15 times 1 is 15. Okay, so how is it that helped us? Well, look over here. The 3's cancel down to 1, leaving x by itself. And that's why we multiply by this thing called the reciprocal. Okay? We say that the reciprocal of 1/3, which we write as 1/3 raised to the negative 1 power, is 3 over 1. Okay? So now x equals to 12 over 15. Well, 12 over 15 can be reduced. So we ask in side work, we say, what is the greatest common factor of 12 and 15? Hey, what is it? Well, the factors of 12 are 3 and 4, 6 and 2, 1 and 12. The factors of 15 are 3 and 5, 1 and 15. So the greatest common factor is 3. So what I'm going to do is divide both the numerator and the denominator by the greatest common factor of both the numerator and denominator. So 12 divided by 3 is 4, since 4 times 3 is 12. Well, 5 times 3 is 15, so 15 divided by 3 must be 5. Therefore, final step, x equals 4 over 5, or 4/5. Put a red box around that. Okay? So, deceptively simple. You know, there's actually quite a bit going on that can tickle the brain of even the smart students that think they understand this. Those can be tricky. All right, now let's look at another problem. 6, open parentheses, x plus 4, close parentheses, equals 48. Okay, here we go. So we'll start off, like every other problem, by drawing our vertical line, just to give us some context here. Now remember, this implies multiplication. Just shoving a number up against that parentheses means multiply. But the presence of the parentheses means we have to multiply the 6 by each thing inside the parentheses. So what I show my students is I draw these little arrows, and I call them distribution arrows, because we have to apply the distributive property and multiply this 6 by this x and this 4. So I have 6 times x plus 6 times 4 equals 48. These are kind of their own little problems, okay? 6 times x is 6x plus 6 times 4 is 24 equals 48. Well, now the problem looks a lot like something we've already seen before. We want to get rid of the plus 24 because we're trying to get this x. So we do inverse operation of addition, which is subtraction. Subtract 24 from both sides. Additive inverses, 24 negative 24, sum to 0. 24 minus 24 is 0, so we just cancel it out. And now we write 6x equals. And now it's time to perform subtraction. 8 minus 4 is 4. 4 minus 2 is 2. Oh, okay, so I've got 6x equals 24, aka 6 times x equals 24. So to get x by itself, I'll divide, since that's the opposite of multiplication, I'll divide both sides by the x coefficient of 6. 6 over 6 cancels down to 1, leaving me with x equals, well, 6 times 4 is 24, so 24 divided by 6, or let's say this fraction, 24 over 6, reduces down to just 4. So x equals 4. Let's put that in a box. And let's move on. Let's see what we got coming up next. Number 5. So number 5 on the quiz, I had an asterisk next to it because there was something weird about number 5. Let's see what's going on. 1 over 2, open parentheses, 6 plus 2x, close parentheses, equals 3 plus 14 over 7 x. Okay. So I want to rewrite this 3 a little bit neater. I want to rewrite this equals sign a little bit neater. Okay. First things first, we come in with the ruler. Yeah, I sound like a broken record with the ruler, but it's really helpful. Okay. Now, remember, it's 1/2 times this whole mess here. And so it's what we really do is 1/2 times 6 plus 1/2 times 2x. Okay? That's called distribution or distributive multiplication. let's write out the whole step here. So it's 1 over 2 times 6 plus 1 over 2 times 2x equals 3 plus 14 over 7x. I'm not going to do anything but one step in each line here. So if you're itching to reduce fractions or something, you'll just have to wait. So let's think about how we multiply a fraction times a whole number. Over here in side work, look, 1 over 2 times 6 is another way of saying 1 over 2 times 6 over 1. Okay, which equals, multiply across the top and across the bottom, 6 over 2. So we're really, say, multiply the 6 times the 1. Don't multiply that 6 times the 2 in the denominator. So 1/2 times 6 is 1 times 6 over 2. So 6 over 2. And we'll reduce that fraction in a second. Now we do the same thing here. Over in side work, look what's going on. We got 1/2 times 2x equals 1 over 2 times 2x over 1, which equals 2x over 2. So 1/2 times 2x, we multiply 2x times 1, and we get 2x over 2. Let's make that look more like a 2. Okay? Just bring everything down. Equals 3 plus 14 over 7x. Okay, now we're going to reduce fractions. So, right away, I can cancel out that 6 and that 2, divide both top and bottom of this fraction by 2, and I'm going to get 3 over 1, which is just 3. Plus, I can cancel out these 2's right here, leaving behind 1's. So I just write x, 3 plus x, equals 3 plus, now 14 divided by 7 is 2. So this is 2x. Now here I tell my students, go in here and put a 1 next to the x over here. It's going to help you avoid a potential issue. So what should we do now? Well, let's subtract 3 on both sides. Okay. The reason I'm doing that is because I can get rid of the 3's. 3 minus 3 is 0, so additive inverse. 3 minus 3 is 0, so additive inverse. They cancel out. And now I have this 1x equals 2x. Many students here have kind of lost the thread because people are uncomfortable leaving one side with nothing on it. But just follow the steps. Just subtract 1x from both sides. Just do that. So minus 1x on both sides. And bring this line down a little bit. Well, 1x over negative x, those are additive inverses, so they cancel and we have 0. Well, now look, 2x minus 1x, if you think about it, $2 minus $1 is $1. So 2x minus 1x is just 1x. So 1x equals 0. So you can kind of flip the positions of these and say x equals 0. And that having that 0 pop up there at the end, that confused a lot of people. Okay. All right. So let's move on. This is our final problem. Number 6. Okay. Let's see what's going on with number 6. This was another problem that had something kind of weird going on. So we have a 5, then an open parentheses, and an x over 15 minus 2 close parentheses equals x over 3 plus 6. All right. Another problem that looks deceptively simple. So we start out keeping it safe. Let's go ahead and draw our line. Now, we know that we're going to have to distribute, multiply this 5 here and then here. We're going to multiply the 5 times x over 15. And we're going to multiply the 5 times the negative 2. Important that we get that negative in there. Okay, so here's what's going on. We're going to do 5 times x over 15 plus 5 times negative 2 equals x over 3 plus 6. All right, so now in side work, take a look. We've got 5 times x over 15. That's this right here, okay? Well, what that is equal to is 5 over 1 times x over 15. Multiply across the top and across the bottom. You get 5x over 15, okay? So here, we just write 5x over 15. Now we do 5 times negative 2. Well, 5 times 2 is 10, so 5 times negative 2 is negative 10. So I have 5x over 15 minus 10 equals x over 3 plus 6. Well, take a look at this. We got 5x over 15. I can cancel a 5 out of the top and the bottom, leaving behind a 1 and a 3. So this really equals x over 3. So I'll cancel 1, 3, and I'll write x over 3 minus 10 equals x over 3 plus 6. Well, now I might add 10 to both sides, trying to get variables isolated. Additive inverses sum to 0, so negative 10, positive 10, we just cancel it out. Now I've got x over 3 equals x over 3 plus 16. This is getting a little bit confusing, but what I really need to do is subtract x over 3 from both sides in a futile attempt to get the x's on the same side. Additive inverses cancel, so x over 3 minus x over 3 is 0. I just cancel them out. But here I've got the same problem. This something minus the same thing. X over 3 minus x over 3 cancels. When you're subtracting like this, it leaves behind a 0. So 0 equals 16. That's what I came up with. Now, here's the question. The question is this true? Okay, is this true? Does 0 equal 16? The answer is no. So what you write is, you write false equivalence, or just false. It's a false equivalence. In other words, 0 does not equal 16. False equivalence, and then you can put these 3 dots that mean therefore. This means therefore. False equivalence, therefore, no solutions exist. Okay? the keywords here are no solution. All right, so this is actually the whole answer here. Just this part here. All right, no solutions exist. Now, if we were to graph the left and right side of these equations, you would see that the lines are parallel. Okay, so we know that parallel lines never intersect, and so that's only parallel lines will have no solution. No solution. Okay, parallel lines. But that's kind of looking ahead to when we're graphing. Just keep that in mind. These lines never cross, therefore there's no solution. And that's why you get something like this. Okay? All right. Well, thank you so much for watching. We just completed 6 math problems where we had to solve for x using a variety of different techniques, including the distributive property, additive inverses, multiplicative inverses in the form of reciprocals, and we even found problems where x evaluated to 0, and one where the problem itself had no solution. So there were no values of x that made the equation true. Well, thank you so much for watching. Hope you have a pleasant day. Thank you. Bye.